Hi guys, welcome back to the channel. I'll show you in a very short video how I made a transmitter for the 144 MHz in the radio amateur band. It's a very simple digital transmitter based on an FPGA. So the only external things are a digital microphone and the output is a DAC, which was built by a ladder of resistors, and a piece of wire as an antenna that you could probably see here. Now I'm transmitting on a short distance, like 10 meters. In a room next to me there is a receiver, which you're going to see in the video, and I'm just talking to the microphone and I'm recording in the room next to me. So this radio is built from three main blocks, which they were presented in separate videos. One video was about how to generate a carrier with digital direct digital synthesis, which is just a block which comes with the Xilinx tools. The second is how I'm decoding and filtering and slowing down, probably I should say decimating the signal down to audio samples from the PDM microphones. Again, it's based on a block which comes with the tools. It's called the CIC filter. I'm not going to go into many details, you need to watch that video if you want. And the third block is a block that I wrote to remove the DC offset in the audio stream, because some of those MEMS microphones they have an offset in the signal, and that offset is shifting your transmitting frequencies. Now I'm going to show a block diagram at the end of the video, but let's jump straight to the EI3 Hotel Whiskey Bravo radio check. EI3 Hotel Whiskey Bravo radio check.
EI3 Hotel Whiskey Bravo, radio check. EI3 Hotel Whiskey Bravo, radio check.
Okay, very quick presentation about the building blocks. So first, this block which I'm going to highlight here is the interface to the microphones. I wrote this in VHDL. It generates the slow clock to feed to the microphone and is formatting everything in an axis stream format. Now, the second block is the CIC decimator, which is slowing down a low pass filtering the signal. So here we get the audio signals and the stream is slowed down. Now I made a video about this, a separate video, so you might want to watch that. Now going further, we have a block which is removing the DC offset. I wrote this in VHDL. I discovered that microphones, some of the microphones, they have a DC offset, which is creating problem downstream. So I'm removing that from the samples. Here we have a pure AC signal. Now the phase increment block is just a glorified adder, so it's just setting the phase increment for the DDS compiler, basically choosing the frequency we want to transmit. I'm just going to open the UI. So you see this magic number. This magic number defines the carrier frequency, which in our case in the demo is 144.2 megahertz. So I choose that frequency for my testing. Now this block is adding the audio samples to that center frequency in order for the DDS compiler, which is just a digital oscillator, to oscillate around that center frequency, which is our carrier. Now, obviously, if we have offset here, that offset is going to be added to that magic number, which represents our carrier, and our carrier is going to move slightly. So that's why we need to make sure we don't have any DC component in our audio signals. Next is just, again, I made another video about this, how we generate the carrier. I'm going to link it in the description. The last block is just formatting the data for the DAC. So it's nothing fancy, I think it's just adding an offset for the DAC. So that is pretty much everything. Is not much in this transmitter. Now there's a block here which is generating all the clocks for the axis stream and the slow clock for the microphone. This is it. I want to keep it short. I hope it's useful. If you have questions, drop me a line in the comments and I'll try to answer that. Thank you for watching.